It's time for another math easy solution to discuss some limits of trigonometric functions. I'll look at a really important one, and this one here. I'll use this a lot in deriving derivatives and whatnot for trig. Trig functions basically the limit as theta or an angle goes to 0 of sine theta divided by that angle is equal to 1. You can't just plug this in because it's going to be sine theta or over 0. This is basically 0, so you're gonna have 0 over 0. These are undefined, so you can't just do that. So to prove this, I'll draw an arc length, or basically here we'll just draw this out. We'll draw it right here. We'll call this length, just draw an arc length like this. So basically, if these are both, let's say our radius is 1, and this is basically 1, they're the same angle, then if you draw the arc length around it, it'd be something like this. So we'll just call this length A. And in my other video, I showed that what radians are. Basically, definition of radians, this is the angle from here to here. Radians are defined as arc length over radius. This is basically what radians is defined as, and since r is 1, this is going to equal to A. So we have A is that, and if we draw a vertical line down here that's perpendicular, then using our sine ratio, we'll just get, well, sine theta is equal to, and we'll just call this length B over R, and R is 1, so B. And we know that basically, well, B is less than A just by looking at it. So then if B is less than A, we'll have sine theta is less than theta. Or if we rearrange this one, we could just divide this by theta, divide this by theta. We'll just get, well, basically sine theta over theta is less than 1. So we'll use this later. So we got this one right here. Basically, well, this has to be less than 1 because sine theta is less than theta. So a smaller number divided by a bigger number is going to be less than 1. So we know this one right here. But then if we were to draw, let's just draw a line that cuts the center of this. So just go, this is going to be a tangent line here. We'll just draw this all the way across. It's going to be a vertical tangent line. So we draw a tangent line across that, and a tangent line across this one right here. This is a bit off. We'll just go here. So basically these two lengths, or make this a bit better. So yeah, if we draw these tangent lines across, this one's going to be vertical straight, because that's at this side right here is going to be vertically straight tangent line. We'll call this length C1 and C2. They should be the same. If you draw it, they're just cutting in half. So basically from this one, we see that A is greater than, is less than, so A is less than, well, C1 plus C2, because of this arc length, it's just going to be less than these two lengths, just by looking at it. And then also, since this line is tangent, if we were to draw just extend this line out, further out, let's draw this perfectly straight. This one's actually, well, this one is supposed to be a right angle here. So I just fixed up how it looks. So basically, this is a right angle across here, and these two lines, this line is corresponding to this, it basically cut this in half. So then A is less than these two lengths because this is just going outwards around it. And then if we call this length right here, we'll just call this D, I guess. So this length is D. So then the A is less than C1 plus C2, but then C1 plus C2 is less than, well, C1 plus D. I'll just show you why I'm getting at over here. And then, well, basically C1 plus D is equal to, what is this one just equal to? This is going to equal to, this is a tangent line, so this is this full length across here, and this is going to just equal to, well, tan theta. Because we know that, well, the tan theta is just equal to this opposite, OP opposite over adjacent. Adjacent is 1 in this case, is 1. Or that's R here, so that's 1. So basically we have this one, this over here. I'll just write it down here. So now we have A is less than these two lengths. These two lengths are less than this full length, which is equal to tan theta. So then A is going to be less than tan theta. So I'll just write the, yeah, and we know that A is theta. So we'll just write it down here. So we know that theta is less than tan theta. So then theta is less than, well, this one's just definition is sine theta over cos theta. This is my other video on trig, on tan, sine, cos functions. Basically, yeah, so it's less than this one. If we rearrange this times by cos, move it over there, divided by out there, we'll just get cos theta is less than sine theta over theta. So now if we put these two together, we'll basically have, we'll have cos theta is less than sine theta over theta, and which is less than 1, which is this one right here. So we have all this. So now using squeeze theorem, you see my other video on squeeze theorem. Basically the limit of well, if we take limit of everything, so limit as, let's say this one's theta goes to 0 of cos theta, this one's equal to, well, basically we'll just write it all down. Limit theta goes to 0 of sine theta over theta, and this one limit theta over 0 of 1. Well, this one, as cos just goes to 0, this is going to equal to 1. So we'll have 1 is less than this limit, sine theta over theta. And limit as, well, this one doesn't even matter. This is just going to equal to 1. So by a squeeze theorem, if these are both equal to 1, and this value is less than these two, then the limit's just going to equal to 1. So limit is just going to equal to 1. So there's our proof. You can see my other video on squeeze theorem, why it's true. So basically, we just proved that the limit theta goes to 0 of sine theta over theta is equal to 1. So there's a proof, the geometric proof of that. And also something useful here is also this one right here. This is pretty useful here. So theta is always going to be less than tan theta, less than or equal to is an inequality that's actually pretty important. I'll show another video on this later. Well, thanks for watching, and hope you learned, and stay tuned for another math easy solution.